All right, let's dive in. Today, we're going to talk about a piece of technology that's, well, it's everywhere, but we almost never even notice it. And hidden inside is this incredibly clever answer to one of engineering's biggest challenges.
And it really all boils down to this one question. How do you take the spin of a motor, which, is just going around and round, and somehow turn it into perfect laser straight motion? The answer, and this is the really cool part, has been staring us in the face for literally thousands of years.
So, for our purposes, let's just call this the spin-to-line challenge. It's this basic, fundamental hurdle that engineers have to clear in pretty much every piece of automated tech we rely on.
I mean, just think about it for a second. A 3D printer. It has to lay down material in a perfectly straight line, layer after delicate layer. Or what about a robotic arm in a lab? It's got to position a tiny sample with microscopic precision. In these kinds of jobs, you have absolutely zero room for error. Any little wobble, any tiny deviation, and the whole thing is ruined.
So that's the real problem, right? You've got a motor giving you all this powerful spinning motion, but the actual task at hand, printing something, moving a part on an assembly line, it needs a perfect, controlled, straight line. How on earth do you bridge that gap?
And this is where our hero comes in. The solution is a component that's so common we just totally take it for granted. But it is an absolute masterpiece of simple, brilliant engineering.
Meet the lead screw. Its entire job, its whole reason for being, is to solve that exact problem, to translate rotation into linear motion. It's the key that unlocks that whole spin-to-line challenge. But to really get how it works its magic, we need to look past the screw itself. We've got to go back to a much, much older and way simpler idea.
Yeah, to really get the genius of the screw, we actually have to unwind it, both literally and figuratively. And when we do, we find this ancient secret hiding inside.
See, the big innovation here isn't about some super complex new invention. Not at all. It's about taking one of the most basic ideas in all of physics, an idea the ancient Greeks knew like the back of their hand, and just using it in a new way. It all comes down to this, the inclined plane. Okay, that sounds a little technical, but it's one of the 6 classical simple machines, which, let's be honest, is just a fancy name for a ramp. Just a simple ramp. We've been using them forever to make it easier to push heavy things uphill.
Okay, now stay with me on this. Picture that simple, flat ramp. Now, in your head, imagine wrapping it around a cylinder. Just keep wrapping it around and around and around. What do you see? You see threads. You've just made a screw.
And boom, that's it. That's the big secret. The threads of a screw are nothing more than a ramp, a really long ramp, just wrapped up into a nice compact shape. So when you turn the screw, you're not really doing anything magical. You're just forcing a nut to climb that very, very long ramp. And that climbing motion, it's a perfect straight line. It is such an incredible aha moment when that clicks.
Okay, but why does this trick work so well? Why is it so effective? Well, the answer is pure physics. It's all about a fundamental trade-off that basically makes work feel easier.
The official term for this is mechanical advantage. And really, it's just a way of measuring how much a simple machine multiplies your force. So, if you push with 10 pounds of force and the machine lifts something that's 100 pounds, you've got a mechanical advantage of 10. It's basically the helper factor.
But, and this is a big but that Galileo figured out, simple machines don't create energy out of thin air. There's no free lunch in physics, right? They work by making a trade-off. You get to use less force, which is great, it makes the work feel easier, but you have to apply that force over a longer distance. It's like walking up a long, gentle ramp to get to the second floor versus climbing a short, super steep ladder. The ramp is way easier, but you have to walk a lot farther.
And that's exactly what's going on with the screw. The more threads you pack in there, the gentler the slope of your ramp. And a gentler ramp means a higher mechanical advantage. Sure, it means you have to turn the screw more times to move the same distance, but each one of those turns takes way, way less effort.
All right, so let's pull all these threads together. What we have here is an ancient, super simple idea, the ramp, that is powering some of the most advanced, high-tech machines we have today. And I mean, this is not a new idea by any stretch. It has this amazing history. We're talking about something Archimedes was studying over 2,000 years ago. It was then formally listed by Heron of Alexandria, and the physics was really nailed down by Renaissance guys like Galileo. And today, that exact same ancient principle is the engine behind our entire automated world, from 3D printers to factory robots. And once you have this ramp analogy in your head, all those complicated engineering terms, they suddenly become super simple. Pitch? That's just how steep your ramp is. A steeper ramp gives you faster movement for every turn. What about self-locking? Well, that just means your ramp is so gentle that friction is enough to stop the load from sliding back down all by itself when you stop turning. And backlash? That's just the tiny little bit of wiggle room, the gap between the nut and the ramp it's climbing. See? It all goes back to that one simple machine.
You know, the incredible power of this whole idea was probably best summed up by Archimedes himself. When he said this famous line, he was talking about the power of leverage, of mechanical advantage, the very same principle that lets a tiny motor turning a screw move a massive piece of machinery with absolute precision.
So, I guess the big takeaway is this. Inside some of our most complicated, modern technology, you often find these simple, ancient, and just beautiful solutions. So now that you can see the hidden ramp inside every screw, I have a question for you. What other simple machines are you going to start noticing hiding in plain sight in the world all around you?